So welcome to Think Tricks, Introduction to Pop, Part 3. In the last two parts, I discussed about Pop workflows and how you can bring basic workflow, like how you can bring. You have two methods. I haven't showed this method in this video. I will show you this how you can bring it. It's like in case if you have a test geometry, then which input is it, first, second, or third or fourth input. Then you have an options called scatter the point. So like, do you have the points from the SOP level or you want me to create it here, and you have those options. And then birth, so it's like when to born, when to birth, or when to start, and how many, how long, and then you need a force to move. Okay, so that's what in the first two classes I discussed. You can see I've added two more picture in this workflow image. Okay, so so I hope you remember. So when to born is this one. It's like you have impulse activation and constant activation. So which one do you want? So impulse is every frame it's gonna emit a count of whatever you mentioned this, or every 1 second, which is constant activation, so which is this count. Okay, so I have added that so that it's easy for you to understand. And I have something else also. So let's start and start doing it. Okay, so I have this page. I have this geometry called intro to pop. So I bring a sphere, a usual sphere. So as a default, I know it's a primitive, so which will have only 1 point. I will raise that up for no reason. Maybe for future, maybe for the next step, like I'll be adding a ground plane. So so this will overlap it. So that's why I'm keeping it in the beginning itself. So I'll keep it like 4. I don't like to move it here. So that's why I used transform, right? So then we bring our pop. Okay, so what I just did, I dragged and pressed tab so that I get the tab menu, and whatever you click, it's gonna attach it for you. Okay, so pop, so I know as a default it is looking for the first geometry, and the emission will be on the scatter on the surface emission type. Okay, so I know it already. So when now I play it, it just, there is no force. There is birth, there is activation, everything, but there is no force. So we are ready with this, and you have some options basically in the SOP. It's like I created a geometry, a sphere. Okay, so you have 3 other options. It's like you can manually select something. So what I mean by manually is, for example, test geometry. I think in the last class I say I started with an I. So it's like you can select. Basically I'll just select this part, and I'm manually selecting it. Okay, so I'm manually selecting it by deleting it. And I can keep this as my particle emitting thing. This black is nothing but it has shop material. I think I've discussed this same in the last part also. So you can just check the add shader, then you see I'm emitting only to the manually selected part, so which is manual selection 1. Okay, and you have group selection and attribute, which we will go. Let's start with the force first. Okay, so I'll connect back to that, and let's go to the pop. So it was kind of recap of everything in the first part and second part. Okay, so so space F, so that I can see where my particle is. So if I play, nothing happens because there is no force. Okay, there is no wind, or there is nothing. Okay, so in here I discuss the first one is pop source itself. Okay, so as a default, I know it is looking for, sorry about that, looking for use inherited velocity. So inherited velocity means it is looking for a velocity in the SOAP level. Okay, but we know that we don't have anything. If you middle mouse click it, there's only position, there is no velocity. Okay, so that's why if I play, nothing happens, because it is looking for velocity in the SOAP, but there is no velocity in the SOAP. Let's go for the second one, inbuilt forces. I will start with inbuilt, and then I will continue with the SOAP level velocity, and then from there I will get back to the first one. Right, so if I press right click, I get a different menu. Okay, and in that you can see force. Okay, so there are a bunch of force, and maybe you will be familiar with gravity force, isn't it? So gravity force, if you click it outside, then you can see there is a force attribute. So if you keep that, you can see force X, force Y, force Z. So force is an attribute, and it has a number negative 9.8. so that value is actually a scientific value. It's a science value, 9.8. If you go to the Google, gravity value is 9.8. okay, so it's not just, it is not a random number, it is actually world physics. And negative, nothing but this is X, this is X, Y, Z. So our gravity is negative, going negative, right, in the real world. So that's why negative. Y plus, Y negative. Okay, so it is going negative, right? So that's why this one, and you can see here it is white and a green. Okay, so keep in mind, whatever you see purple has to connect with purple, and white has to connect with white. Okay, so which means this cannot be plugged over here, it's an error. Okay, so but you can connect it here, no problem. So now if I press play, I change the value somehow, play, then you can see it's going downwards, just the way we want. All right, but you can also see it's white and white here, so of course you can connect it over here also, so you get the same. So you can connect it anywhere. It's but the highly suggested will be here. Why? It's because gravity is a universal force, isn't it? It's like in the real world we have wind, we have someone pushing, but there is a global force happening in our world, which is a gravity. So gravity is basically a universal kind of force. It applies for everything, isn't it? For us, for human, for table, for chair, for everything. So it's better to connect in the end. Okay, so after the solver, if you connect it here, there is no problem. I don't know the exact scenario to explain, but universal it is. Okay, so all other forces, if you check any other force, like drag force, even that is white. And if you look for other field force, even that is white. So basically this force tab is a universal. It all has a white input connection. Okay, so we're not gonna go any of this for now. Okay, we are going for inbuilt pop tools, which is this one. This is the one we are going to explain. I'm going to explain. I'm not going to explain the entire one. I will be explaining the frequently used and very important thing. Okay, so you can explore, feel free to explore all these node. To give you us a little bit of a summary, it's like you can play around any of this except pop steer. This steer thing is for crowd effects. Okay, so it's better you when you are doing crowd, you can play around with these inbuilt tools, but you can play around with other any of the stuff. Okay, so let's start with pop force. Okay, and I'll get rid of the gravity so that, because I want to explain how pop force work and stuff. So if there is a gravity already, then it is a little bit hard for me to explain what's happening in the pop force. Okay, so let's see if everything is back to normal. Play, nothing, no force. So if I apply pop force, nothing's gonna happen because we haven't applied any of the force. Okay, so the pop force, you can see force and 0 0 0, and there is noise, and avoid this binding and input for now. Not for now, for most of the time you won't be, as a beginning stage, you don't need these two, only this. Okay, and yeah, so let's start with this is vector. So you can see 3 channels, x, y, z. So if I keep it in the y, I mean in the x, then you are not able to see anything. It's like you are like, what's gonna happen, is that which part is x. Of course you can check it over here. This is x, so yeah, this is x, so this is x. So if I play, it will be going on the right. Yes, it's going on the right. Cool. So you can have a guide even before what you are planning to do. So if you click the guide, then you can see, okay, you can see there is a guide as a red line. It says that it is going this side. That's first, in the beginning it's hard to understand, but you will eventually understand which side. Okay, or otherwise you can go for it like this too. So yeah, now you can see, right, it's going this side. So if I play, it is going exactly where the guide says. Okay, so you can play around with the force. Okay, so I'll talk about the what's happening. Okay, so force, I'll get rid of the guide and I play. I'll give a big M value and I play again, so it's faster. So you can see it's fast. It's the speed is so, like, it's going so fast. Isn't it? It started off slow and then from. Okay, so what's happening here is, so let's go to the geometry spreadsheet, and in the last class as I discussed, you can go to the pop object and geometry. Okay, and you can get rid of all the other by hide all, and you're just, you're not deleting it. When I say getting rid, it's like this is a lot of attribute, but I just want to see, or just want to watch only the force. Okay, so in the beginning itself, you can see here force is 600 and it's 00, right? So it's exactly same as what it is here. Okay, and I'll bring velocity as well, because when a force applied, there will be a velocity generated. Okay, so I want to show you how the velocity is moving. That's why I'm keeping it here. Okay, so to make it very simple, I'm keeping everything here. I have force and velocity, so 6 and 000. So when I play it, you can see, you can notice, so you can see here the velocity is moving because force is applied, 6 force is applied, and it's moving. So you can see it is keep moving. The velocity is like going crazy. So that's what's happening here is, you can see in every 1 second, okay, every 1 second, it is, the velocity is reaching trying to reach this value 6. Okay, so you can see here in the 48 you'll be getting almost 12 and 18 almost, like that. So let's, if you don't trust me, let's go for 10. Okay, so force is 10, so every 24 you can see it will be 9.5. yeah, and again here you can see 18, 20, yeah, 20, 19.5. so every second it is trying to reach, the velocity is trying to reach this force value. So that's what's happening. Okay, so it is a constant movement. So that is the one I want to show. So I'm going to discuss pop wind next, but in the pop wind it says that unlike pop force, so pop force is which is continuously accelerating particles. Okay, so this is what I want to show. Pop force is a continuously accelerating particles, because that's what we can see here. It's continuously accelerating that value. All right, so that's what pop force is continuously accelerating. And this you can play around the value you want, however you want to go. So I'll keep a value of 4 for now, and you can add noise. So I'll put back the guide. Okay, so that I can see how the noise is working. So as a default, it is amplitude is 0, so which means there is no noise. But as it increases, you can see, you see, there's a noise, and you can play around with the swell size. Swell is, you can see here, kind of making a pattern for you. No pattern, some pattern. Okay, so as you increase, there's a noise pattern, swell size pattern for you, and you can increase the scale, and you can play around. And since you have the visual, there is no point of explaining each of this. You can play around and find it. Okay, so I will turn off the guide, and now you can see it's going to have a noise. So from, all right, so that's what pop force is. All right, so let's look for pop wind. Okay, so pop wind. So when I keep pop wind, there's a new lot of new stuff has come. Target V and target V, which is a 4 vector. Target V 0, 1, 2. I mean 3 vector. Sorry, come on. So, but we're not going to discuss about target. But you can see here there is an air resistant, right? So I'll turn off this, and I'll keep this. And there is no force, because instead of force, so pop force has a force, right? So instead of force, wind has velocity. It is directly applying to the velocity, right? And there is an air resistant. Okay, so and you can see a similar stuff like what pop force has. There is a group, guide, same thing, group, guide, and noise, binding, and input. So I'm not going to discuss like there's no point of discussing the same, but I'm going to discuss about the velocity. All right, so let's go for keep a x-axis 4, and now you can see since it is a pop wind and it has a resistant. Okay, so pop wind, what it's going to do is, you can see the velocity will be reaching 4, not beyond 4. Whatever value you give, that's going to be the velocity. So if I play, you see it is not going above 4, right? So it's just trying to keep it between. So let's make it 2 to make it clear. So you can see it is trying to go, you see it's not going above that. It won't go above that. That's what. So that's what wind velocity. So wind velocity applies wind to particles by updating their target V and air resistant attribute. Okay, so I will bring the target V here, and you can see it is 2, and so velocity, the velocity is target is 2. Okay, so that's why it is trying to reach 2, not above that, because the target has set to be 2. Okay, so which continuously pop wind instead act as a drag, pulling up particle to the ambient wind speed. Okay, so what we saw, it won't go beyond that. It just keep that value and move that way. And air resistant. So what is air resistant? So I think I'm clear about velocity. It's like whatever you keep the value, it will be the target. Okay, so not like pop force, which is like, which goes which the velocity will continuously accelerate. So pop wind, yeah, this one, it's very direct. I'll go some swirl and that, and if I play, I get the same as before. Pop force, because the noise pattern thing is the same as like whenever you see noise and this thing, it'll be same. The concept is same. Okay, and so I will turn back into 0 so that I can show you what's air resistant is. Okay, so air resistant is 1 at the moment. Now I want to show you 72, and it is here. Okay, it is here. So as I decrease it, so if I keep it 5, okay, so the higher the lower the air resistant, the pulling will be stronger. Okay, so 72, this one. Okay, so let's go again, and 72 with the half, you can see it won't reach the 2, it will be in between. Yeah, you see the 2 is here, but it's here because it's dragging it. Okay, so that's what air resistant is. When do you use it? It's like, I'll give you an idea. So I have an amplitude, and if I play now, it will be little slower as I go lower to the air resistance. So you see it's little slower. Okay, but the target will be the same. Target will be 2, but it's the reaching the point from one place to another to reach will take a little bit time, but you will be seeing it is going, the wind velocity will be 2, but will consume more time. Okay, so pop wind, I like using pop wind a lot than pop force, because pop force is gradually accelerating, so I don't like it. There's few more things to cover, so which we will be going for curve force and axis force. Okay, so let's go for the axis force first. I keep it aside, and I'll apply axis force. Okay, so what's axis force? So as soon as I keep an axis force, you can see another red, the guide is turned on, and another red spear on the 000 position. Okay, that's nothing but, it says here, it is written here, there is a spear type and the sender is 000, so that's why it is, the spear is in the middle. Okay, and the directional axis is 1 at the moment. Okay, so if I play it, you can see nothing's going to happen. That's because the type or the spear is far away from this. It has to be the point has to be inside the sphere to make the axis force work. Okay, so I will manually move it. Come on. So I will manually move it. You can move it from here. Okay, so I kept everything, and I am not sure that the points are all inside. So what I'm going to do, there is a radius and height that I can play. So I'll make a radius a little bit like that, and I will make a height a little longer. Okay, so like this. Okay, and the axis force is in the y-axis. You can see the white. So if I keep it here, then you can see the guide going this side, right? So for now, let's go to the y-axis itself, and let's play and see what's going to happen. For this, I don't have to do any math explanation, so I will just take it off. Not needed for now. So now if I play it, oh, you can see something happening. Yeah, you see it's orbiting. So what's happening here is this is shape tab, so you can adjust the shape however you want, and you have two options, torus and sphere. So in the speed, you can see the orbit speed is 1, so that's why it is orbiting. It's orbiting. That is the reason why it's orbiting. So you can increase however you want. So now you can see it's orbiting so fast, and as soon as it goes outside of this this axis guide, it is spreading. So that's because the axis force is happening only inside. Okay, so you can increase it if you want. So now if I play it, then you can see in this part you can see the orbit happening, and the rest is like a splitting, spitting out. Okay, and I don't want 200 and stuff, so I'll keep it 1 so which means 1 the plus or minus 1 plus 1 equal to 2, and 1 minus 1 equal to 0. So in between 0 and 2 the value will be, so it's gonna die somewhere there. It's looking good. I don't have much particles. It will look more good if I have a lot of particles, but as you know, the more particles generate, the slower the speed will be, the computers. Okay, so let's go to the speed, and now you can see everything is on the flat surface. So what's happening here is the lift speed is 0. That's why. So if you keep it a little bit, that you can see it will start to lift. So yeah, you see it started to lift. So you have something cool. I like it. Okay, and section is nothing but section is like it will try to keep everything inside this sphere. So if I increase it, you can see it is trying to keep everything inside, and as I go down, you can see it is losing. Okay, so section is basically it will try to keep everything inside, and lift is basically lifting it. Right now it's not going to lift. Okay, so that's what it is. And fall off, soft edge, it is very hard to show what is soft edge. What's happening here is when it is going outside this boundary, it will have a soft or smooth going outside. When it's going outside, it will have a little bit of smoothness to that, but it's very hard to show what's happening here. So yeah. And outer strength and inner strength. So right now inner strength is 1. That's why you can see everything is here. So if I keep it 0, it's not going to work because there is no inner strength. So if I keep it, I have the inner strength. Like if I keep it 0, it's not working. Okay, but same thing, if you keep it outer, it's not going to work. But if you say inner strength, so right now it has an inner strength, so it will start moving it. Okay, and outer is also once, but now you can see it is not doing anything, because even here now you have I will bring it 10. Now you can see it here. So you see even outside also have the same orbit and lift and section thing. So that's what inner and outside, outer. Okay, and this is not it. It's like you can actually mix pop wind and pop force and all of that based on what's your need. So now I'm gonna make a little bit of noise because this doesn't have a noise, right? So I'll keep it. Now the noise is not that big. Okay, maybe because even outer also it has a lot of strength. Okay, so now when it go outside, it will have a pop wind. So let's go outside. Yeah, you see it has a noise, and I have a resistant. That's why you can see it. So I'll keep it resistant back to 1 because there is another node which is dedicated for a resistant. So for now, yeah, you see it's getting interesting. I like it. It's getting really interesting. Wow. I never thought about this. I can make it a little bit more fun with this. So I'll make it 8 so that there is a little height. Yeah, height, more height. Yeah, it's getting interesting. Okay, so when it goes outside, that's where I want. When it goes outside, there is something called pop drag. So drag, you can see it here. It has only 2 things: wind velocity, air resistance, just like pop wind has wind velocity, air resistance. But pop drag doesn't have a noise. Okay, so that's why I said this is more of a dedicated for air resistance. So I use pop drag only for air resistant thing. Okay, so I keep it 0.1. Now when it's go outside, probably somewhere here it's gonna go outside. Now you have a slow things. Okay, so which I kind of like it. So that's what pop axis, pop wind, and pop force is. Okay, so now let's bring another source. Okay, so another source, we can bring a pop location. I haven't brought that yet, so a quick one. I will bring pop location. So just to discuss that, like I don't like using this pop location, so I will just connect this, and for the sake of explanation I'm bringing it. Okay, I'll quickly explain this, which is, you can see here in the first option, dynamic level, you are bringing a point. Okay, so this is soap level, I'm bringing a point, but this is dynamic level, I'm bringing a point. Okay, so I quickly explain that. So you can see here, whatever pop source has, like birth, attribute, stream, binding, and source, The same thing you can see here for pop location, birth, attribute, stream, and binding. So it's actually same, but pop source basically have an option called bringing bringing outside or inside, or bringing the points or source from outside. That's the only, I mean, that's the benefit of this. But pop location, you cannot bring anything from the source level or SOP level. It is in the DOP level itself, so it is same as that. So when I play it, you can see it is emitting. You see it is constantly emitting 5,000 births. So that's what this dynamic level pop location, dynamic level bringing source, which is pop location. Like, who wants this? We can basically make the same thing in the source level, and we can have a lot of control. In this one, we cannot control, at least other than the position. So this is where the 1 point is, like 5.2, like this is where 1 point is there. So 1 point will activate this with a 5,000 birth count, and with this life expectancy. Okay, so I don't want that. I seriously don't like it, because we can do much better. All right, so let's bring a merge. I'll show you what I'm going to do with the merge. Don't worry about this sign. It's because it is in the frame 60, and it is looking for the result, but there is no result, isn't it? So orange is nothing but, it's like error, not error. I haven't calculated. Like, this is not an accurate calculation. That's what orange means. And when you see blue, which means this one is accurate one. Accurate, like if you turn back, you get the accurate simulation result. And if you keep it here, so this one is basically like I haven't calculated. Okay, so blue is calculated 100%. Okay, and this part is I haven't calculated. So you can get that situation when you have a lot of points. Right now I have a decent point, that's why it's calculating as I move. But if you increase the birth, then you can find what I'm trying to say, which is orange and stuff. You can see there's sometimes even you can see a gap of this in between. So that's nothing but, that's like I forgot this part, and now I remember only where the blue is. Okay, so that's because it's a compute memory thing, computer memory thing. It's like it has a limitation that you can control it from cache. So in the cache, you're saying I need what's this, 5,000 MB. I don't know if it is 5,000 MB, but 5,000 is the default memory. So if it is above this, then you can probably see a empty gap, but I won't suggest increasing it. We have another method, so I will go through that in a minute. So let's get back to the SOP, and we know manual method and geo method. Let's go for a group selection method and attribute method. So first, let's start with group. Let's go for Taurus, and again I'll keep it on the side. So I will make a group. I hope you watched the group video. It is a 2 video, I guess. If you watch it, you will understand Please watch it. That's why, please watch it, so that because I'm not going to explain what's going to happen here. So I will go to the bounding and I'll get a box. For now you can take any. So I'm making it faster. So this selected part, okay, so you want to generate points only to this, only this part you want to emit points. Okay, so I will connect to the second, right? And of course you can put, of course there is a way to say that, like you can say scatter points only to the group. Okay, that's one method, but I want to show you how you can do that in the pop. Okay, so now, okay, so this is actually called series method. It's like everything is stacking a series workflow, I would say. Like we have two workflow for Houdini, one is parallel and one is series, and of course one is mixed. So here this is series, it's like everything is stacked under, and I'm gonna bring a new source, pop source, and that I'm going to have plug it here. So it's like there is series of one source and series of pop source one, which is basically a two parallel thing. Okay, so I go to the second contest and scatter on surface. So now you can see it is scattering everywhere, isn't it? But what I want to say is take the group, isn't it? So in here you can see there is source group, and if you come here and group, you see you get only that part. Okay, so that's what this second group selection, you can generate points or have points using the group. Okay, and the next method is attribute based. You can bring it. So I'll go back and I will increase rows and column, because I want to make an attribute, right? So easiest and fastest attribute is paint attribute, painting the color attribute. That's the easiest one, and the mask also is the easiest one. So yeah, let's bring mask. Let's bring mask instead of paint. I mean color, because color, it will have a black, I mean the value will be yeah, I will just show you why not color. So why not color? So if you check this out, you can see it's a color attribute, and if I paint it red, I'll paint it red. If I paint it red, and if I go check the geometry spreadsheet, you can see everything is 1. You see, everything is 1. There is no 0, because this is also considered as a white. Okay, so white is, you know, right, white is 1 1 1, and red is only 1 0 0. Okay, so when you're painting it, then what you have to do is you have to first say that it is everything is black. So it's like you have to paint everything black first. You have to paint everything black. Should be an easy method to paint black, but anyway, black, and then you go color red. So now if you come to the spreadsheet, you can see there is black and there is red. Okay, so that's what color paint has a problem. It's like it will see it as a, like we have to paint 2 times, one black and then red. But mask is faster. Mask, whatever you paint, that part will be mask 1. Okay, so that's a faster way to do stuff. Okay, so you can delete the group because I want to show you attribute based bringing points. So you go scatter, and then in the density you say that mask. So you are selecting only that part and you're spreading points on that part only. Or you can go directly inside in the pop source. Instead of emission attribute, you can go for, instead of group, you can go for mask. So you can see, I hope you can see, I can get rid of this. Yeah, you see, wherever I painted, I have a scatter on there. Right, so that's what attribute based. You can use color attribute, any on attribute, or mask, or anything. Okay, so I hope you understood completely about bringing the source and manipulating all this. Manipulating all these and birthing about impulse and constant, and we discussed a little bit about the inbuilt forces. So we can continue with the curve force. So curve force on this. Here on the left we have the axis, still we have it, and the curve force is the one I'm going to talk about. Okay, so let's bring a curve, because why I'm bringing curve. So if I go to curve force, okay, which is right here only, go pop force and curve force, curve force, yes. As a default, it is looking for a geometry. So it is actually looking for geometry, and we don't have a geometry, isn't it? So this curve force is looking for a curve. I hope you watched my donut. So in the donut, I'm discussing about the curve tool. So let's see where my, this is where my object is. Okay, so I just want to have I just want to know where it is. So I will make a curve, something like this. It can be anything. It can be polygon, knobs, anything. I'm looking for knobs so that I have that curve. It is not, the edges is not sharp. You see, it's all sharp. So go to the nerve. So everything has a flow. Yes. And I will bring a null. Why null? Because I just want to name it null, and I can say curve. Okay, so I can either bring this, or either bring this by going manually, okay, out curve, or I can just copy and paste it. It's like I can take a copy, Control C and Control V. Okay, Control V. All right, so that's one option. Or I can go for the contest. So I think it is in third contest. Yeah, third contest. So I can go for the third. Anyway, it's the same. So you can see the curve that I drew here. I got the same thing, but now I have a guide which says that which has a thickness or a radius. So that radius is influenced here. So as a default it is 2. That's why it became 2. So if it is 1, it will be like this, and 2. I think 2 is decent. And also I can see some of my particles are outside. okay, which is not that good, but let's keep it 2 then. Yeah, now everything is inside. All right, so now on the left we have axis force with wind and drag. On the right, for the torus, we have a pop curve tool. All right, so now if I play, and also you can see the arrow is downwards. Okay, so that is actually coming from how I drew. So I started drawing from here. Drawing from here. So that's why they thought, okay, it start from here. That's so then it had the curve has to go down. Okay, so how do I make it back? Then I can just go reverse, I believe. So yeah, you put that reverse, then the arrow mark will be opposite. All right, so now if I play, you can see it's going up, and this is going also up. So it's based on the curve, it's following. Okay, and you can move it anytime. So I will just move the I keep a transform, and I will just move it like this, and it will update. So every time in pop, when you're doing pop or when you're doing any simulations, always go for the first frame to update it. It's like if you are here and then go back to the first frame, and it will update. So otherwise it will be yellow or orange. I don't know what color is it, but I think it's an orange. So now if I play, so here you can see a same kind of channels that we saw in the axis, which are orbit, lift, and section. You can see the same section, orbit, and velocity, and follow. All right, so follow is what will help it to follow this curve. Okay, so if I keep it 10, it will follow fast. Okay, and section, like I said, it will try to keep it inside the tube. And orbit, of course, orbit will spin. So if I keep it 10, then you can see it is spinning, and you can see some are going outside. So let's keep section to, I don't know, 6. So it is trying to keep it everything inside the tube. Okay, isn't it amazing? So that's what pop curve force is. And you can see here follow scale, and there is a custom parameter for you to adjust. And similarly, you can see section field, section scale, and section custom option, orbit custom option, and in-head velocity custom option. And the air assistant is there so that you don't have to create a drag. You can control it from here, or you can put a drag. It's up to you. And make sure you kind of cover everything with your curve tool. Cover the points. If you have a points, and you have the curve tool, and then curve has the tube has to be the point has to be inside the tube. Okay, so, and what's this ramp? It's very easy. So it's like the pop scale is, the follow scale is 10, isn't it? So the top part will be 10, down part will be 0. Okay, so which means this is at the 0 and this is at the 10. Okay, so when it start, it will follow, and gradually it won't follow. Okay, so that's what you can see it here. If it is a long one, then only it's easy to explain, right? So same thing with section. So section also, I gave value 6. So the top part will be 6 and down part will be 0. So which means at the beginning it will be 0, but gradually it will be 6. It will be 6. So you can adjust it. Basically you can adjust follow also, you can adjust it. It's like you start slow and suddenly go fast, and then go slow, and then go fast, and then go very slow, and then go fast. Okay, so let's see what's gonna happen now. Yeah, it's hard to say, hard to tell that. So I will bring, okay, something like this. So it's, I think I have to, okay, now you can see. Yeah, you see it changed because I'm giving less. So now if I give more, then you can see again, slow, slow, slow. Yeah, because I said slow and then rise it up. So that way you can control all of them. And there is a global force also, globally how you want the force to act, and even that has a ramp or remapping parameter, so you can adjust the way you want. So I'll take it back to this, and of course even this you can give a pop wind. I'll copy and paste it, copy, paste it. So if it goes outside, then you can see it has a similar behavior. And there is another thing called pop color. So you can give to a color. So I'll give this one red, and I will give this one green. So when I play, yeah. And another extra tips that I want to give is like, it is keep emitting, isn't it? What if you want, you know, after 48, not 48, after 96, I don't want to emit any more points. Like whatever there is a point, it has to fade off. So to do that, what you can do is you can animate the activation 1 and 0. Like here you can say 1, and wherever you want to have it turned off, then go there and keep it 0. But the better or easiest way is, like when you are doing that, the problem is it's like it has to calculate this much, isn't it? For example, if you're keeping here, it has to calculate this much, and then you change it, isn't it? So instead what we can do is we can say $frame is less than 72. So what's this? So if we click here, you can see here it is 1. So in the beginning it is 1. So what I said is, if the frame number, this number, if it reached 72, $frame is less than 72, then it is 1, and if it is greater than 72, then it is 0. Okay, so you can see it here. I'm pressing 1, so now 72, you can see it's 0. As it reads 72, it's 0, and 70, it is 1. It is 1, it is 0. And you can see, so I'm giving the same expression for this as well, with a different number, $F greater than, less than 80. Okay, so now if I play after reaching 72 and 80, yeah, it's going outside and it's going outside. I hope you like it. Okay, so those are the two techniques that you can use it, and there is a couple of things you can also add. So it's like, for example, what if you want only the first frame? Okay, so if you want only the first frame, then the expression is equal to 1. Okay, so $F equal to 1, which means I want to generate uh, points or points only frame 1. So now if I play it, then you see only it generated frame 1. Okay, so it depends on your situation what you want to make it, but I'm just saying that you can do greater than, or if you keep it greater than, then it won't like if I keep it 70 greater than, then it will be 0 in the beginning, and as it go up 72 it start playing. Okay, so yeah, whichever fits in your idea. Those are the main inbuilt forces that we're gonna use again and again and again. And there are this we're going to learn in a rain and snow effects, and pop kill. Okay, so I'll show you what is pop kill, and pop limit is actually same, but pop kill, I will show you what is pop kill. So pop kill, you go to the boundary as a, you can enable the dead one. So it's like, well, let me tell you what is pop kill, then you can judge. So pop bounding box is the one I'm taking it, and I will make the size bigger. Okay, and the position. Okay, so I will make it so I made a box. Okay, so which means if the point hits the box, then the box will kill the point. There won't be any more points on or above this box. So you can see it, you see if it is inside this, then it won't. You can see this doesn't have it. That's because we stack to this one. This, even if it is going inside this box, it doesn't matter. But if you keep the pop kill here, so now you can see I have two stacks or two series, or parallelly keeping two series of emission, and but both has a pop kill same, both share the same pop kill. So now you can see even if it is going there, it won't go there. Okay, so to make it more clear, let me size it like this. You can see it's gonna die. See, so that's what pop kill is. And I think I pretty much covered the main stuff, and the property, a little bit of fluid, the collisions, attract will be covered in the coming classes, and warp. So that's it about the inbuilt forces, the main inbuilt forces. Now let's get to the point velocity.